All right, let me bring you back together here.
Guess who it is?
Okay. Here's the idea as we move forward here today. We'll go through the warm-up in just a second. What I will tell you is these three problems would be a sample type of problem from each standard coming up on the test next week. Okay? What I'm getting at is, last chapter is when we talked about, in chapter 2, we talked about area. So this first problem would be a problem that would be on like the geometric connections part of your test, because it's from a previous chapter, you've had chances to work on it, and we'll go through that in a second. When you get to problem number 2, this is some of the main ideas with the similar triangles. This is some of the main ideas of the current chapter. So this would be a geometric reasoning type of problem that you would see. As a matter of fact, I think I've told you before, and I'll tell you again, this is something you will see on the tests coming up, these types of problems. Okay? And then the last one, problem number 3, is an algebraic connection type of problem. Yes, it's about geometry and finding area of a shape, but most of it is dealing with this x minus 3 and being able to come up with the algebra. Okay? So kind of like a sample problem from each standard on the test. Today we're going to get into 326. It's the final lesson of this chapter. It's just applications of what we've been doing. We'll talk about that. We'll get into that. Tomorrow then will be your team test, the chapter 3, where you have an opportunity to work together and on that. And then next week we'll get into the chapter 3 individual tests, closure type stuff, and that idea. Okay? Let's start with the first part here. It's problem number 1. I asked you to name the shape. What kind of shape is this?
Trapezoid.
And let's go even a little more specific.
A regular trapezoid. Isosceles.
Isosceles trapezoid. Okay? Because of the fact that you've got 2 equal sides out of the 4, that's what makes it an isosceles trapezoid. So then I asked you to write down the formula. Here's where you might have needed or used your formula for a trapezoid. So there's your formula for finding area of any trapezoid. Not that you have to do the whole thing. You could break this into pieces and find it. I know people that did that. That's fine. I'm going to go just with the formula, though, because we have one. It's one of the shapes we actually have. Do me a favor real quickly. Let's take all the iPads and put them flat, please. Too many people messing around and not paying attention. Okay? I want you to be able to understand this. I already know how to do this. Okay? I want you to learn it. I want you to be able to do it so that next week you can show that you can do it. Okay? So I would like you listening to what's going on here. So in this case, that means there's 3 pieces that I need in order to find this area. The 2 bases and then the height, which in this case, I already know one of the bases is 10, and I already know the height is 4. So the rest of this problem is kind of going through and finding the bottom portion here. Based on the markings, I know that this piece is 5, just like the other side. The fact that the height is 4 over here, I could translate that over. That means I know this is 4. So we can start penciling some things in. The fact that the top base is 10, I can slide that down. That means this piece is 10. But that only goes to here, which means I need to find the bottom 2 pieces. Okay, Lilith, what do I do?
You use the Pythagorean Theorem, or it's 3 because like 3, 4, 5.
Yep. So either option. What you needed to notice on this, you have a right triangle, you know 2 side lengths, and therefore that's Pythagorean theorem every time. Okay? So if you solved it, x squared plus 4 squared equals 5 squared, you would get 3. Or, like Lilith said, if you just know that this is a Pythagorean triple, you could just write it down as well. So that's 3, which, by the way, then, because this is an isosceles trapezoid, means that this is also 3. If this was not isosceles, you don't know for sure that these match up. That's why the isosceles part was important. Okay? Therefore, the 2 ends are equal. And now you've got all the information you need in order to find the area. Now you can plug in your information. So base 1, we'll call that 10, plus the bottom now has a total length of 16, so we can put that in there. We've got a height of 4. Divide everything by 2, and now it's back to order of operations again. Right, start in the parentheses, get an answer, We've got 26 times 4 is 104, right? Yeah. Divided by 2 takes me back to 52. So we've got an area of 52. What are the units on this one? Yeah, feet squared because of the fact that it's an area. Okay, you end up with square feet. All right, so there's the first part. The other part I asked you to go through and find the perimeter. Well, now in this case, because we found all of the pieces, all you have to do is just add it up. So perimeter on this one, if we do add all this stuff up, I should get 36. And what are the units on this one? Just feet. Okay, perimeter, remember, is just the length. So there's one problem. There's one that's fairly straightforward, hopefully. Okay. Any questions before we move on? All right, let's keep going. So now, number 2. I asked you to determine if the triangles are similar, okay, first, and then justify how you know by writing the appropriate similarity statement. And then again, what I told you before is the by line, what I'm looking for is, was it because of angle? Was it side? What was the reasoning behind it? Okay, the justification. So let's actually start with that. Because if they're not similar, then there's no reason to write a similarity statement. Okay, we don't need to do the first part if the second part isn't even true. Are these triangles similar?
Yes.
Okay, why? Why, Ariana? Okay, yeah, if you take a look, the information that is given, you've got 2 sides and the angle between, 2 sides and the angle between. So that side, angle, side, the one thing you have to check is to make sure that the sides are in the same ratio. It's not just because you have side, angle, side, you got to actually check the side ratios. And in this case, if we look at, we got a zoom factor of 3 here in this case. Okay, so we do have side, angle, side, similarity. There's the by. Now let's finish the triangle, the similarity statement. What letter would come first?
Y.
Okay, if you go through and we're trying to match up A, notice A is at the end of the longest side, and so is Y. Okay, you can kind of match that up. How about B? B goes with X, and C therefore goes with Z. There's your similarity statement. Okay, just matching everything up, and it's because of side, angle, side. If we go to the next part, and this one you're going to actually see, it's going to come back here today again in the lesson as well, this type of problem. Let's go to the by part first. Similar triangles? Yes? No? Why, Rebecca? Yep. So this is just a dilation from one smaller triangle down up to the bigger one. So you could say angle F is the same angle in both triangles, so it's congruent to itself. So that's one. And because of the parallel lines, what kind of angles do I have? Corresponding. So therefore, I know that this angle has to be congruent to that one. And if you even wanted to, you could go even a step further and know that those have to be equal to each other. Okay, so it is angle, that's good. Which means now, let's finish up the similarity statement. If it's FOT, similar to? FBA, yep. Hey, again, you're just kind of stretching it, you're just dilating it. And there's that part. Okay. Like I said, this is what we're working on right now. This is one of the main ideas. Do we know if 2 triangles are similar? Okay. You will see problems like this on the test. All right, then the last one. This would be an algebraic connections type of problem. Because of the fact that we've got the congruent markings, I know that all of these sides are x minus 3. Okay, so therefore this is a square. Key part here for a second. I asked you for the area of this shape. How do I find the area of a square? In general, base times height. Okay? Well, the base is x minus 3. The height is also x minus 3. So we just need to multiply x minus 3 times x minus 3. That's where the geometry ends, and now the rest is algebra. Okay? Doing the algebra. What if I would have said, by the way, quick question, because more than one person in here did this. What if I would have said 4 times x minus 3? What am I actually finding? Yeah, that's the perimeter. Okay? If you went through and you took x minus 3 times 4, that'd be the expression that would represent the perimeter rather than the area. So now, let me refresh your memory 2 different ways as we work our way through this. Option number 1, we can FOIL this out, do all the distributing. So if we take the x and distribute, x times x gives you x squared. X times negative 3 gives you negative 3x. Then we take the negative 3 and distribute. Okay, distribute one term, then distribute the other. We get another negative 3x. And then we end up with a positive 9. Only thing left to do then, just clean up combined like terms. Okay, things along those lines. Wow, Mr. Coonan's here. So we've got x squared minus 6x plus 9. There is the algebraic method. Okay, there's the algebraic answer for the area. Let's say, quick reminder, by the way. If you don't like the foiling idea, different way of organizing it. Remember back to the box method?
You taught the box method.
I don't teach it, I just show them. Here's the box method. There's one x minus 3, here's another x minus 3. And now if you just multiply, you fill in the boxes. X times x gives you x squared. Negative 3 times x gives you negative 3x. Another negative 3x. And then we end up with a positive 9. What I want you to notice, you get the 4 terms that are in the box are the exact same 4 terms you got when you FOILed it all out and did the distributing. Okay, so it's the exact same process, it's just a different way to organize it. Okay? What do you got, Mr. Coonan?
Do you try and get the chicken?
Yeah, we're going to.
Let me, can you give me access?
Oh, yeah.
I'll show them the result wherever they want to get to.
Let's take a look here. Let's take a look at what Mr. Coonan's going to here.
It didn't work in all classes, but some people it works for.
Let's see here.
What room number is this?
229.
Because
Is that Belchin-Dotsky?
okay, so hey, this is where you want to get to. What happened?
It died.
Let's see if it works out. Look in the mirror. Look in the mirror. Look in the mirror. It was like half hour ago. What? See, it worked. It worked.
What happened?
Did you just?
Here,
Did you replay it?
Yeah.
Get your. Okay, so I gotta touch this. Oh, come on. Which way? Oh. Yeah. I need help. Oh, there it is. I got it. You gotta get it louder.
You gotta turn your volume up on it.
Yeah, try your phone.
Okay, we're rocking now. Calculations right? See, there it worked. It worked. Well, that's what you guys got to figure out. That's what you got to figure out. See if it works for you guys, okay? You'll figure it out, but that's what it's supposed to look like. Okay.
There we go.
There you go.
Thanks for visiting.
No problem. I thought you might-
That was perfect timing. All right, you want to know what Mr. Coonan's talking about?
Not really.
Too bad, you're gonna anyway.
Cancel out. We're good.
Yeah, we're good.
Too bad.
All right. Here's what you're taking a look at today. So, in the last section of chapter 3, we're doing applications of similarity. These are the super realistic applications today. Okay? Here's what Mr. Coonan's talking about. You see the "you are getting sleepy" part?
No. Oh yeah. I can't quite see. I'm getting pretty sleepy.
So, number 1 problem, our realistic application day. Legend has it that if you stare into a person's eyes in a special way, that you can hypnotize them into squawking like a chicken.
Oh, that's cool.
So that was the video. He was squawking like a chicken. Or she was, I think. I don't remember who was in that one.
That was a guy. That was a guy.
I don't know who it was. Whatever. I don't remember. I wasn't paying that close of attention.
It's non-binary.
Whatever.
Very much of a woman.
So,
She plays.
place a mirror, notice, on the floor. Your victim has to stand exactly 200 centimeters away from the mirror and stare into it. The only tricky part is that you need to figure out where you have to stand so that when you stare in the mirror, you're also staring into the victim's eyes. And then if your calculations are correct, they squawk like a chicken. That was what Mr. Kunin was showing you, that they did the calculations, squawk like a chicken, there you go. So, here's what we're going to do. Here's what I want you to do. Here's where the fruit snacks today are coming into play. We're going to put some fruit snacks on the line here. So here is the picture. Okay, here's the squawk like a chicken picture. As we take a look, so if you're going from this guy's eyes, and we go straight down to the floor, then there's a certain distance he's away from the mirror. By the way, what does this line represent? Well, it is, but in real life, what does it represent? Yeah, it's his vision. It's the line of sight. So he's looking down at the mirror. Okay, notice? Created a triangle. Then, over here, the other person, same thing. Looking down from their eyes at the mirror. Certain distance away. Standing straight up. There's the eye height. Okay? Here's your first job for today. On the back side of your warm-up, what I want you to do real quickly is draw these triangles, okay, or at least sketch them.
Maybe I sketched something else.
And I want you to tell me, with your group, discuss, I'll give you a minute or two here, why or how do you know that those two triangles are similar to each other? Okay? How do you know? And I'll call on a random group. Okay? And I'm not even putting any numbers in this picture yet. I'm not even going to put any numbers. Why are those triangles similar? Okay? Talk to your groups. I'll give you a minute or two here.
Well, no, because then they're not the same. If they were short, this triangle would be shorter.
You guys on your phone back there.
I will tell you this, because there's good discussions going on. Let's assume that these two people are not the same height. Because if they are the same height, that's way too easy. And most people are not the exact same height as somebody. If you pick two random people out, they're probably not the same height. So let's assume those people are not the same height. Okay? And if you can answer this with a well thought out and good justification, that's where the fruit snacks are coming into play. The whole team gets fruit snacks if you can put this together with a good, solid answer. Okay? I'll give you another minute. There's only going to be one. We're going to randomly select a team here. Huh? Don't worry about the numbers yet.
Mr. Biggie, are the triangles similar? Are you sure?
Similar. That's why I switched it to different heights.
Yeah, it's the same thing. It just depends on how far back they are.
Keep right. If you stand where the tall, that's when you can
That is another thing I'd like you to do. If I select your group, pick your representative to explain. You got to pick the representative. Be all on them in order to explain fruit snacks for the group.
We believe you, but we
You're smart. You got this.
Are we ready? No, not yet? All right, one more minute. I'll give you a minute and 10 seconds.
I'm the culprit. This is weird.
They stare. Yeah, but they're both exactly 2 centimeters away from different heights. So it just feels like if they stare at them,
Why are we losing brain cells? He's just laughing. Not even putting up a fight, just laughing. All right, here we go. So here's how we're going to determine which group gets selected. So I've got a 10-sided die. We don't have 10 groups, but it'll work. Okay? I'm going to roll a die. This will be group number 1. Group 2, group 3, group 4, 5, 6, and 7 in here in the middle. Okay? And we'll see whichever group we roll, and we'll see how the quality of your answers. Okay? We have group number 5. Who's the rep? Or do we not? You are? Okay. It's got to be good quality. If it's not, why are those triangles similar? Be specific. Okay. Where are the? I will give you that it is angle. Where the heck are the angles? Okay. Why? Remember back to the mirror? We talked about anytime there's a mirror, the angle in and the angle out are always the same. Good. Keep going. Assuming that these people are standing straight up. Okay. Well, in this case, in order for this to work, we have to. So we do end up with angle because of that exact reason. Very good. Well done. Here come the fruit snacks. Incoming.
What if I intercept one?
Over here, Mr. Biggie.
There we go. All right. Now, fruit snack opportunity number 2. Says here, we're going to make up some numbers. Says here, they said your victim has to stand 200 centimeters away. Let's go with some feet instead. I'm going to change the units to feet, even though it's a lot here. So if the victim is 200 feet, we'll say feet away, because it makes more sense. That's a long ways away. Yeah. Okay. Now, I said let's assume that these two people are different heights, because like I said, in real life, most people you randomly select are probably not at the exact same height. So let's say that this guy is approximately 6 feet tall, up to his eyesight. And let's say that this person is approximately 5 feet tall. Okay? The problem says you have to figure out how far away you need to stand in order to then look directly into the mirror. So this is what we're looking for right here. Find x. You got 2 minutes. 2 minutes to find x. And be able to explain how you got it. Okay? Find x. Ready, go. Knowing that the triangles are already similar. We've already discussed that. You got 2 minutes.
Oh, that hurts.
I am not the best.
Okay, so 6 divided by 5.
We do not think it's smart. You think you are very smart. I'm not as good. Mr. Biggie, I think I have an idea.
Okay?
Do you want to be my ambassador?
More room to do the work. Okay? Maybe. You might be right. You might be right.
Stacy?
I got my answer, and it is 175.
I thought it was.
We got about 1 minute left. 1 minute to get the answer and be able to explain it. Bless you. Yeah, we're gonna. That way it's fair. That way it's fair. Huh? That's a true statement. It's not. That is not. Is not fair.
Unfair to everybody. Isn't that technically being fair?
That is fair, right? Also true. Good point. All right, here we go. Let me roll a die. Let's find out which group we got. Group 2 over here. Who's forfeit? You can if you choose to.
Lose. Pass it on to 7.
We got it, or are we passing?
Pass it on to 7.
Pass it.
Pass?
Go.
All right.
Pass it. Right over here.
Group 4.
Pass it. Pass it on.
Do we have an answer?
No, you.
Pass it on.
Okay, so who's the person?
Rebecca, you lie.
All right, quiet down. Now, let me ask you first, what's the answer? Let's start there.
Wouldn't it be 200 feet since each person was supposed to be
200 feet. Wrong answer. All right, we gotta go to a new group. Gotta go to a new group. Group 3. You hear it? All right. What's the answer? The answer is 240. Quiet down. Now, explain. Why is it 240? How'd you find it here? Okay, if we take a look, listen up, please. You got a couple ways to do this, but if you heard what Tier said, because we already know these are similar, he set up his ratios. You know the side lengths then have to be in the same ratio. So he took 6/5. Okay. Those are the corresponding sides. These are just reflections of each other, but a little bit different size. And therefore, x/200. And now if you solve the proportion, cross multiply, divide, you do get 240 as an answer. Anybody do it differently out of curiosity, by the way?
I did 6 divided by 5 and got 1.2 and then just multiplied that with 200.
Okay, so another option, you could have found the zoom factor. Turns out the 6 divided by 5 is 1.2. There's no rounding, it's exactly 1.2. And then you could have used the zoom factor, that would work as well. Okay, very good, all right. Here's incoming. And one for you too. What? Over here, Mr. Biggie. There we go.
You got it right.
Next.
He said he likes the seams on your pants.
Yeah, I did give you a.
All right, here's the next problem. Here's our next opportunity, our next super realistic problem, okay?
Okay.
So LaToya was trying to take a picture of her family in front of the Big Ben clock tower in London. However, after she snapped the photo, she realized that the top of her father's head exactly blocked the top of the tower. Couldn't see a thing. All she got was her dad. So while she was disappointed with the picture, LaToya thought she might be able to estimate the height of the tower using her math knowledge. So if you remember, we talked before about like indirect measurement of if you can measure stuff on a smaller scale and then blow it up, you can always go through and do that concept. That's what we're going to take a look at here. And so here's the different measurements. She took the picture while kneeling, so the camera was 2 feet off the ground. It was also 12 feet from her father, that's 6 feet tall, and he was standing approximately 930 feet from the base of the tower. Okay? Here's question number 1. And I'll give you about a minute or two on this one. Where, if I'm looking at this picture, where can I draw in a line to create two similar triangles? Okay? Where can I draw a line in here to create two similar triangles? Okay? Discuss. I'll give you about a minute. 1 minute to discuss. Where in this picture would I draw in a line that would then create two similar triangles that I can then work with? Where can I draw a line in here?
Are you? You gotta make it.
Are you? Are you? Did you listen to a word he said?
No, I didn't.
You're doing wrong. You have to make two similar spaces. It's okay.
Alright, you're the spokesperson.
No, I'm not.
I don't know what you're talking about.
Neither do I.
I said. We're not getting fruit snacks.
Okay, no, we're not gonna. No.
All right, do we have a volunteer on this one
Yes.
that has not earned fruit snacks yet? Any volunteer to figure out where you think we should put this?
I don't get what you're asking.
Where am I going to draw a line to create two similar triangles? Anybody? Rebecca, you think you got it? No? Okay, fire away. I like it.
Could you draw the line from the top of the guy's head across?
So, like here? Is
Yeah.
that what you're talking about?
And then you can do yeah, and then you do from the camera to the
Like this way?
yeah.
Here's what I'll tell you.
You got a bunch of stuff on the bottom.
It does not create a triangle.
Yes.
Sure.
But that's cheating.
Yeah.
There's a triangle, right?
That's not what I was
I'm not even. Not even close.
Yeah, I knew you were.
That line.
But no.
What if I'm sort of right?
What?
See what you, I'm sort of right. I talked about
I have a different one.
That looks great.
There's another triangle, right?
Stop.
Are those triangles similar? Going back again, by the way, remember in the warm-up? Remember that problem right there? That I told you was going to come back? Where you got a triangle that dilates to another triangle? That's exactly what's going on here. I'll give you credit for that, Rebecca. You get one of those. Good work. All right. So, now, here's the next one. Come on. Next opportunity. Let's put some measurements in here. First question, because we're comparing the red to the green triangle. First question, what's the length of the bottom side of the red triangle?
That would be 942.
Okay? The bottom triangle is the total of both the 12 and the 930, so 942. What's the bottom of the green triangle? That's just the 12, right? Okay? So there's a ratio right there. There's two sides that go together. As long as we're in the green triangle, what's the height?
4.
What is it? Why 4, Emily?
I believe it is 4.
Yep. This camera, so he's 6 feet tall, but this is 2 feet off the ground. So you got to take that 2 away, and so we end up with 4 right there. And now what we're trying to figure out is the height of the tower. So I'm going to kind of put an X here. Find X. Okay? We know the triangles are similar again. We know they're similar because once again we have right angles. We've got angle-angle similarity. We've got 2 questions left. One of them is what is X? The first one's what's X? Hang on 1 second. All right, let's take a look. Keith, you think you got it?
I think I got it.
What'd you get?
X equals 314.
X does equal 314. Now, that's not the last question, though. First question, where'd you get it? How'd you do it?
I divided 942 by 12.
Okay, so you found the zoom factor.
Yeah.
So what'd you get?
78.5.
So if you compare their sides, 942 and 12, that means the big triangle is 78.5 times bigger than the small triangle. And then?
So multiply 4 by 78.5.
And therefore you get X. There you go. Now, last question. That's not the height of the clock tower. Anybody tell me what the height of the clock tower is?
360.
Why? Yeah, don't forget that the camera's 2 feet off the ground here. Therefore, you got to add the 2 back on at the very end. So the actual total height is 316. Okay? All right, your assignment. Worksheet 326 is the last one for the packet. Tomorrow, chapter 3 team test.
Can I have a snack?